All right, so hopefully you've conversed with your person next to you and tried it out for yourself, but we can go through it like this. I'm going to highlight my variable terms, and I want to combine like terms. So I say 2x plus 5x, that's 7x. And I have 7x plus 9 equals 30. You can draw your railroad tracks, training wheels, or river, whatever you want to call them. Be able to add the opposite to both sides. So I say minus 9 to both sides. These cancel out. So we have 7x equals 21. Divide both sides by 7, since that's our coefficient. And we say x equals 3. Again, notice how it takes about 30 seconds to work on a problem. Be able to check it as well. So we do 2 times, we're saying x equals 3. So we say 2 times 3 plus 9, and then plus a 5 times 3. We're saying, does that equal 30? So again, we do 2 times 3 is 6. So we say plus 9 plus 5 times 3. Still do multiplication, so we do 15. Everything else stays the same. This is also 15 plus 15, which that does equal 30. So we know our answer's right. Again, you're trying to make sure that both sides of the equation are the same. In the last partner problem, you guys notice that the variables are on different sides, and we'll be working on this very shortly. But what do you guys think we can do? How do we get all of the constants on one side? We have to add the opposite. So maybe do the same thing. How do you think we get the variables all on one side? Very good. You have to add the opposite. And so I'm going to add a negative 3x to both sides. I add 3x, or negative 3x to both sides, because that cancels out on the right. Everything else stays the same. So we have the 6 comes down. 4x minus 3x is 1x. And then we have the minus 8. Just like we've been doing, add the opposite to both sides. So we have plus 8 to both sides. So we have x, and then we have x equals, yes, 14. Let's see if this is correct by checking. So we say, does x equal 14? We have 4 times 14 minus 8. And we have, is that equal to 3 times 14 plus 6? So we say this is, let's see, 56 minus 8. And we can say that this is 42. 42 plus 6. And yes, this does end up working because both sides are 48. Since that is good, we can check it off, and we are good. To show what this looks like in Desmos, I will demonstrate. The way it would work is like this. Let me scoot this over a little bit. So we say, let's see. Let me see if we can zoom in a little bit. Alright, so what I'm saying is this. I type the first expression. I say 40, or not 40. Let's say 4x. I say minus 8. I hit enter because that's one expression. And I say 3x plus 6. Does this equal each other? Well, we have x equals, and then 14. Since both of these are equal to each other, meaning they're both equal to 48, we know that these are correct.